Our final chapter of 6th grade math is about probability. We will start with theoretical probability. So first, some vocabulary. An outcome is a possible result of an experiment. So say our experiment is we're going to flip a coin. One of the possible results is heads, the other is tails. We're not going to talk about the possibility of a coin landing on its edge, or like throwing a die and it somehow landing on one of its points. We're going to assume, for the sake of our own sanity, that coins will always land heads or tails. If we throw a die, it'll always land on 1, 2, 3, 4, 5, or 6. If we spin a spinner, it will always land in a section, not on the edge of a section. And this is just to make our mathematical lives easier. The sample space, now, is the set of all possible outcomes from an experiment. So if you flip a coin, the sample space is heads or tails. If you throw a die, your sample space is 1, 2, 3, 4, 5, or 6. If you pick a digit, your sample space is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Probability now is a measure of the likelihood of an event, ranging from the number 0, which means it's completely impossible, to the number 1, which means it's certain. Christmas will be in November would be an impossible event. Christmas is never in November. It's December 25th. Easter comes after, the probability of Easter coming after Ash Wednesday is 1. Easter must come after Ash Wednesday. That's just how things work. Ash Wednesday happens in late February or early March, and Easter happens in late March or early April, depending. Theoretical probability. So written P, parentheses, event in parentheses, is the ratio, fraction, of favorable outcomes to the number of possible equally likely outcomes. And you can see that as a formula here. The probability of the event equals the number of favorable outcomes over the number of possible equally likely outcomes. And if it's a fraction, we will reduce it. And complementary events are two events whose probabilities add up to 1. So, Brenda and her 11 classmates have their names placed in a bag. Find the probability of drawing Brenda, P Brenda. Well, Brenda is one name. One of the names is what we want. So there's one outcome we like. How many names are in the bag? Well, Brenda's and her 11 classmates. So that means there are 12 names in the bag. So the probability of drawing Brenda is 1/12. Consider choosing one letter from the word challenges. Find the probability of a consonant, the probability of picking either an E or an L, or the probability of drawing a vowel. So, how many consonants are there in challenges? Well, let's see. C-H, L-L, N-G, S. That's 1, 2, 3, 4, 5, 6, 7. So there are 7 consonants. Let me clean that 7 up. There are 7 consonants. How many letters are there total? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters in the word challenges. Yes, I'm aware that there are 2 L's and 2 E's, but they are separate letters, so they each count. So you have a 7 out of 10 probability, 7/10 probability, of drawing a consonant. The probability of drawing an E or an L. Well, how many E's and L's are there? There are 2 L's, there are 2 E's. That means there are 4 letters that fit what we want here, being E or L. So there's a 4/10 probability. P-vowel, we have 2 choices in how we figure it out. We can go through the word and look at all the vowels. Or we can realize that P vowel is the complement of P consonant. Because you can't be both a vowel and a consonant, right? Those are complementary things. They would make up the whole set. So the probability of drawing a vowel we could get by doing 1 minus 7/10. 1 is 10/10. 10 minus 7 is 3/10. We can confirm that by looking in the word and saying, hey, there's an A and 2 E's that are vowels, so 3 letters do match up. This is an example of complementary events. We can use complementary events to calculate probabilities. If we know the probability of one of the two complementary events, we can just subtract it from one. So consider rolling a fair 6-sided die. Find P4. Well, there's 1 4 on a 6-sided die, so that's one outcome we like over 6 possible outcomes. 1/6 is the probability of rolling a 4. Probability of an odd now, well, the odd numbers on a die are 1, 3, and 5. There are 3 of those, so there are 3 events we like, and there are still 6 total outcomes. That fraction simplifies to 1/2. And then we have another complementary event, the probability of not 4. Pardon me. The probability of not 4. Well, the probability of not 4 is the opposite, the complement, of the probability of 4. So you'll see I've made a note here that we can do this as 1 minus the probability of 4. Well, P4 is 1/6. Remembering that 1 can be written as anything over itself, so we're going to say it's 6/6. 6 minus 1 is 5. There's a 5/6 probability that we're going to roll something that's not 4. And that checks out, because if we think about it, the things that aren't 4 are 1, 2, 3, 5, and 6. There are 5 numbers that aren't 4. And last, consider spinning a spinner that has 8 sections. 2 are yellow, 3 are blue, and 3 are red. Find the probability of not spinning blue. Well, how many sections are not blue? The ones that are yellow and red. 2 are yellow, 3 are red. That means 5 of the sections are not blue, and that's what I want here. I want not blue, and there are 8 sections total. So there's a 5/8 probability of not blue. The probability of red now, there are 3 sections that are red. So 3 that are red over 8 total sections. And P not yellow. Well, not yellow means either blue or red. There are 3 blue and 3 red. So that means 6 sections aren't yellow, and there are 8 sections total. That fraction does reduce, so the probability of not landing on yellow is 3/4.